Again, thank you to our panelists for their opening statements. Thank you to our corporate sponsors for MathWorks for our particular session. I guess this is your opportunity now to ask questions to the panelists. You can either do it through the chat, and in which way I can relay questions, or you can raise your hands and I will be more than happy to relay, or Diana would be more happy to relay to the panelists. So while we wait for those questions, maybe I can start with one question which relates to education again. And that is that a lot of ECE departments have built over the years a lot of infrastructure regarding teaching laboratories that are predominantly hardware oriented, whether that's maker spaces, IoT, embedded system circuits, you name it. The question here is, what is the analogous infrastructure that they should be thinking about if they want to think about the data science laboratory? In other words, what would be sort of the data science makerspace, or should there be such a thing? Any of you can address this, maybe Rich, maybe you could start since you haven't really started.
Yeah, I was jotting some things down. I was really taken by what Stephen said, and was actually writing an email to my department colleagues at Rice around this. And yeah, I would just say, so I think that the simple, obvious answer is that if you're going to want to teach students about how to do modern machine learning, for example, they've got to have access to modern computing, right? Which is GPU clusters, and then training on all of that stuff. And they need to know Python, right? And not some of the other more classical languages. And I think all of that is pretty well known. And IT departments at a lot of schools are starting to build computational infrastructure for undergraduates that has like significant GPU capability. But just sort of riffing on what Stephen brought up around talking with a computer science colleague whose eyes glazed over, who didn't know what a differential equation was. I think another way to answer your question is that, what is special about ECE in this space as opposed to just straight ahead computer science? And I would argue that it is really the interface with the physical world, right? Like we don't use, I've tossed around the term physics like 18 times, but that really, it really is the physical world that we deal with. And so I would argue that in addition to just providing computational labs for students, that you should look at these real world labs that have been built, right? Control labs, Lego type labs, circuits labs. And I think a real opportunity exists to bring data tools into those existing labs. So don't get rid of your circuits lab. Just think about how circuit lab concept experiments could motivate data science kind of ideas. So that's my too long answer, but yeah, hopefully that makes sense.
Does anybody else want to follow up on that excellent point?
Yeah, I will. I was just gonna say, I think I agree with everything Richard said. And George, you brought up a very good point about these labs. And I think maker culture is incredibly important. And I think spreading that to some of the more mathematical courses that we have in ECE, I think is absolutely critical. So if you ask a student, why are you taking, why are you majoring in computer science, not EE or something like that, or ECE? They'll say, oh, because, we take these classes and we immediately can do stuff. We're empowered immediately. So my feeling is that we can actually do this. I think that, for example, when you teach a linear algebra class, it can be a math class. They have that in the math department, and that's cool. That's fine. But when we teach it, it should actually have a maker culture imprint. Or I like to say this, that linear algebra should not be a spectator sport. Uh, it should be, students should be doing it. You know, I personally, sorry, but I wouldn't recommend MATLAB, but you know, they could be doing, although it's a perfectly charming language for linear algebra, if they should be doing this in Julia or Python and following it that way. So, and actually what that does is that empowers them. I mean, that's kind of the whole point of sort of the maker culture. It's like, you can build something and it's cool and it works. And I'd love to see that culture diffuse into our more mathematical classes, which are things like the statistics and the linear algebra optimization.
Agree.
Maybe I can just quickly follow up this point about bringing more computation and data analysis into the existing math courses. You know, this could range. I already talked about the linear algebra course in which this was very much done. This was completely enriched by including Julia to have students be able to try out many examples, many applications, but also I think in terms of how we teach signal processing, or you know, some of our core fundamental courses, which students like very much. They view it as math courses. I heard actually one of our students say about signal processing that was the best class. They realized that when they were graduating that was the best class they have taken in their curriculum, although they did not know about that when they were taking it. So I think this point about Stephen's point about, you know, being able to immediately see the impact and why we're actually learning these things. And I think computation and data science provides a great opportunity for being able to introduce that immediate impact in application. So that's very much principle I think we're using in reforming a lot of the curriculum in our department.
Thank you. Again, if you have any questions, raise your hand, write it through the chat, or just take the microphone. So let me then ask a question. Another question, I think Richie brought this up, which has to do a little bit with, you know, with this, I mean, I think actually all of you brought this up, which is the issue of culture, that there's a slightly different culture between what you would see on the EC side and then other parts. And also given the intensity regarding the conferences, how should we be thinking about this as department chairs when it comes to things like mentoring, embracing faculty in these directions, or tenure and promotion, things like that?
I don't know if maybe I can stop Richard if you want to.
No, you go first.
No, I think it's very important to think about, you know, junior faculty mentoring and be able to, you know, create mentoring committees. That's not necessarily just from EC, but, you know, drawing from expertise from other departments, being able to connect them also with, you know, relevant researchers in other departments. We see that, you know, if they're working in areas, suppose we have a person working in computational fabrication. So that's not just in EC, that's an area represented very much in McKee, in other places. So actually trying to create a research, you know, family and group for them that sort of transcends departmental boundaries is important, and important to also, you know, be able to support them through this rich connections and networking possibilities, collaboration possibilities across departments.
I would just add, I think, yeah, that's, I totally agree. I would just add that as far as mentoring both young faculty and also students, it's complicated by the fact that many of these young faculty, they just come from a different world, right? They like, I grew up in a journal publication world, right? A paper with like fine wine, right? That became, that you worked on for a long time, and then it took even longer to finally come out in publication. And now it's, I don't know if this is, it's almost like papers are fast food now, right? They're these little 8-page nuggets. And if you're lucky to get your paper into the conference. You're one of 2,000 papers in some of these conferences. It's crazy, right? So I think it can be mentors who are maybe older faculty, more established faculty who are still very used to the journal publication world. It's just they need to realize that the folks that they're mentoring, and particularly even their own graduate students, don't have necessarily the same experiences, and the can be kind of disheartening sometimes to students, right, and to young faculty. So I think this is I don't have any silver bullet, but I think ECE is really in a place where there are unlike computer science that's kind of gone 100% over to this conference model, ECE kind of sits in between. So I think it's just difficult. I don't have a silver bullet. Maybe Stephen does.
All right. Okay. I think yes, Assad, go ahead again.
Yes, the panel presented interesting and a lot of important information regarding the importance of AI. And I'm looking from an implementation point of view from a department chair that we have been using AI courses as a technical elective. So this is how we have been offering them. But given the importance of AI, and it's not going to go away, and it looks like at least for the foreseeable future, would that make sense to that this course or courses become a part of a requirement for all electrical and computer engineering students? And if so, given the fact that we are having all these restrictions from the universities limiting the credits for graduation, is there any suggestions from the panels where to look into to basically incorporate this thing as a required course, if that be the desired path? Thank you.
Should I jump in or
go for it, Asu? Yeah, go for it. Yeah.
There's a lot of discussion going on now about, this is, so I'm going to switch gears a bit. The EE side of our department also is undergoing a lot of discussions about how to reform or revitalize the EE curriculum. And the discussion was, mainly focused on what is the core? What's the requirements that we would like to have all our students know? Should we have very restricted core? Should it be flexible? So that I think is something we've discussed quite a bit, and mainly converged to the fact that it should be something in between, not super strict that we want electrical engineers to absolutely know X, Y, Z, but that we still want some core, some fundamentals that sort of our students, graduating students, can build upon. And basically in that core, data-driven approaches, this is not completely an AI course. It's basically control and dynamical systems using data-driven approaches type of methodological component seems to be an important piece of the core that we're defining there. So my answer would be, we do need students to know about this very powerful sets of tools and methodology. But in terms of, several different machine learning AI courses, I think those could be very much, things that they can have choices around. For instance, one thing we're very much thinking about is also organizing our curricula around tracks that students can actually think about, because EC is so broad, goes from hardware algorithms all the way to data. I think it's important for the students to be able to make choices with some fundamental core that we can give them, and along those choices make more deeper selections of deeper subjects that they would like to take in AI or in other fields.
All right, Stephen, it seems that you would like to go next.
Me? Oh, yes, I was agreeing very much with Asu. So Assad, I think you brought up a very important point about what what should be required. And as at MIT, at Stanford, we've been having very intense discussions, kind of passionate discussions, as you might imagine, about this topic, actually for the last 20 years. And actually, I guess I can speak as someone who changed his opinion on this. And so 20 years ago, I thought, oh my God, we should require more. I mean, look at people coming out of MIT or Berkeley or Illinois. They know so much more, so we should add more requirements. Actually, what happened is we've actually greatly reduced the requirements down to a very small core, and the sky didn't fall in. And in fact, I can report that I remember someone in one of these discussions saying, like, if we do that, the students could actually construct a valid trivial program, right? And they could avoid all hard classes or whatever. And I remember thinking, oh yeah, that's right. But it turns out that's true, they can. And I'm not saying that no student ever has, but generally they don't. But what we've found by loosening the requirements and offering tracks, I think as Asu said, is actually it's been a lot. It's a much better, it's a much more fun department. We get people who like co-major in music or in theater and dance, believe it or not, and they're constructing their own. We have a core, and they construct their own. They choose and pick courses from CS, statistics, outside, the humanities, and it's actually been a lot. I think it's actually been a huge improvement. So I'm a big fan of, even though it sounds weird, to actually cut back the core to a very small number of courses, and then let other students, let the students choose which other courses they take. Now, you mentioned you asked whether AI courses should be pulled into this core. And that would depend for me on what you call an AI course. If it's linear algebra and probability, the answer is, for me, yeah, absolutely. If it's like deep neural networks for NLP, my answer would be absolutely not. So just to express an opinion.
Thank you, Stephen. Rich, you would like to add, or would you like to go?
I think that's great.
All right, Magnus, you're next.
Yeah, I actually wanted to add something to that, because I'm not a panelist, but I'm going to do the organizer's privilege anyway and weigh in. What Stephen said resonated a lot with me, and we all know that addition is a trivial operation in curricular matters, and subtraction is hard, and people are very passionate. And what we did at Georgia Tech a few years ago, we were locked in this curricular revision where we asked the wrong question, which is, what should every electrical and computer engineer know? And the second you ask that question, everyone starts piling on. Oh, it's exactly what I do. At least 3 courses in controls, right? So instead we asked, what do you think everyone should know? And then we took the intersection operation instead of union operation. And our core became the intersection of what everyone thought rather than the union. And it was a very small core that everyone could agree on. So just from a school chair's craftsmanship, the intersection operation is really effective. The union operation is wrong, because then you just get this bizarro card castle.
Oh, if I can add my comment to this discussion, if I may, the question should no longer be what is electrical engineering, but rather what you can do with an electrical engineering education, which very much leads to the tracks concentrations discussion that we just heard. Let's see if there are any other questions. So I would like to ask a little bit, Asu, you brought up this excellent point about humans and affecting humans and incorporating humans in the design. And I was wondering what's the role of AI into it, and whether you see that there's an opportunity to grow sort of the intellectual dimension in that direction. And how should we think about it? Because this is a dimension that's kind of very sparsely populated in EC departments, and actually in engineering departments, I would say.
In, I think, many departments, even in CS, this is something that's sort of very, hasn't, it's growing in importance, but hasn't, attracted much attention so far. I personally think it's an important interface that we have to embrace, and I hope I was able to convey why. I mean, of course, technological development, designing these AI systems with the many metrics that we consider, in thinking about how this development should take place is very important. But if you think about it, at the end of the day, this sort of very powerful methodology will be deployed very much in societal applications. And I think without considering its implications, the promise can easily, I think, turn into a technology that doesn't necessarily improve welfare, but create a lot of unintended issues that we will have to deal with. Right now, the ones that sort of are in the horizon are very much about all this, bias issues, impact of algorithmic decision making driven by AI very much, methodology into several aspects and facets of our lives. Future of work is a big discussion, thinking about how it affects jobs, impact of automation technologies. Overall, I think thinking about AI, computing technology, data science methodology, how it will impact, how we're going to be able to deploy that. Sort of that, I think the human aspect, as well as, this responsible deployment, social implications, is something that should not be considered, but very much be part of the design process itself. So that's why I was trying to make that point. And I strongly believe sort of this human modeling, although has not been an integral part of EC, is something that's, I feel very, is a conceptual thinking, which is very close to ECE thinking, because this is very much about decision making with multiple agents and thinking about control when you have multiple agents in the loop, cooperation, collaboration, competition aspects. So I think all of these are things we think about in our methodology, and combining that thinking and viewpoint with the design of these systems, I think would be increasingly important as we're thinking about deploying these systems in, more societal applications than just the vision tasks or the games, we're thinking about.
Yeah. Any other comments or questions? I'll keep continuing if there's nothing. That's my job as a chair. Let me continue with the next question. All the panelists today come from the more, let's say, algorithmic side. But there are other dimensions also to data science and AI, closer, say, to computer engineering. And I will also ask Diana if she would like to take the role of a panelist here to tell us a little bit about what are some of the opportunities, scientifically, research-wise, but also education-wise, that they see with kind of on the interface, let's say, with the beyond Moore's law meets data science, AI, meeting together somewhere in the middle. I know it's slightly out of scope, but I think in the interest of expanding the discussion, an area that I think is within the sort of the realm of EC topics.
Yeah, so actually your point is excellent, George. So one thing that we're, coming from the computer engineering side of the world, what I think is really important is to understand that we're talking about AI and data science because we were able to build the machines that made possible the 20, 30 layers that Asu was mentioning earlier in deep learning, right? Need to put together computer engineering and electrical engineering to advance AI and data science. So one thing that I think is really essential is making sure that we have the right computer systems, hardware, devices, circuits that will be able to push forward the field. And at the same time, put machine learning and AI in the loop to help us get there. So of course, we are, for example, at UT in the process of creating this or building on the strengths that we have in both computer engineering and machine learning, foundations of machine learning. But what we're thinking of is what are the machines that will lead us to the next generation of AI and data science? So how can we push the field further? Because the current, SIMD machines or hardware platforms that we have will do so much. So we need to think beyond that. What are the things that is not yet possible, but we will be able to make possible? So the connection between the hardware platform and the infrastructure is really, you cannot break that from the algorithmic and model side. So it's really essential to do that. And I think there's a lot of richness and opportunity in how curriculum can help pushing that agenda, not just on the research side, obviously, but also on how we train our students. Because we can say, okay, we have the track on data science and machine learning, we have the track on architecture, computer systems, or embedded systems, but the question is, don't we want our students to know both? Because otherwise we won't be able to advance the field. So there's a lot of opportunity there. And of course, it's really something we have to embrace. And yeah, there's room for computer science as well, because computer engineering typically sits in both EC and CS, unless you have a ECS department. And there's also opportunities obviously with statistics, data science, but other fields in engineering as well. So absolutely, I'm a computer engineer, so I agree with Jelena that EC should be, should take over the world, but at the same time, computer engineering is one of the engines needed to make that possible.
Let's see, any final questions? Okay, so maybe I'll ask the panelists for any final thoughts they may have about before we close the panel. Any final remarks you would like to say based on the discussion you've heard today, any words of wisdom for all the department chairs that are listening in this Zoom session?
Want to go first, Sue?
Okay. I think I will probably repeat myself in saying, the opportunities that we're facing are vast, and it's a very exciting time to be a department chair. I never thought of myself as a department chair, just as a disclaimer. But it has been fun because it's not been business as usual. We're really thinking everything from scratch, all the curricula, innovations, reorganization of everything happened in the last 2 years that I've been a department chair at MIT. So it's been a very interesting experience, and it very much comes with the opportunities that we're facing in deploying these technologies today. I just want to underscore though something we discussed before. I think in the curriculum reforms, this sort of being flexible, because our discipline has become so broad, and not insisting that you need to know XYZ to be able to become X, or I think that's superbly important, and trying to go beyond boundaries and just do good research, good impact, and be after exciting work and things that excite us, as opposed to these norms and things that sort of constrain us because of historical traditions. I think is very important for us to embrace at this point, at least of EC. Thank you.
Thank you, Asu. Stephen, you'd like to go next, or Rich?
Sure,
Stephen?
sure. I think it's a very exciting time, and I think it's obviously a time of transformation of ECE. I think I think I can speak frankly when I say that a lot of people in EE, especially, are actually kind of existentially threatened right now. And I've had colleagues actually just openly admit, they'd say, like, I don't know, when I went into EE, we were at the top of the pyramid, and now, CS has taken over. And so the nice part is we have actually, EE and ECE have actually had other times like this, these transition points where the field actually changed. And I think it's very exciting, the stuff we can do now. Actually infusing all these things with maker culture, I think is super exciting. I have a colleague who referred to our EE curriculum once derisively as delayed gratification with nothing at the end. Meaning you would just like, right, this is a a while ago, but basically it meant that you would sit there and you'd make root locus plots, or you I don't know, design some op amp and test it with like Spice. But the point is, nothing ever happened. What's so cool now is that actually a whole lot of what people do in EE and ECE can actually be done. And I just think that's super empowering for the students. Honestly, it's super fun for us. So I think it's an amazing, it's an inflection point, but a super exciting one.
Thanks, Stephen. Yeah, I've heard it being called the broccoli curriculum. Eat it, it's good for you. So that's exactly the point. Okay, Rich, so final thought for the whole panel.
Super brief. I don't think I have anything to add. Those were very clear. It's a very exciting time. This is a transformational period. I mean, ECE departments will be substantially different in a decade. I also totally agree that we need to focus on the many opportunities and not on existential threats. And just look at all of the there's a massive investment in this space, not just from industry, but now from government. That means the sky is really the limit. And so I think that, there's just tremendous opportunity, and it's just great to be in ECE today.
All right. On that positive note, we have the transformational time, and we'd like to thank our panelists for showing us the way through this period. And I hope you've all enjoyed the sessions today, and looking forward to seeing you all tomorrow. Magnus, any words of wisdom from you?
No, I think this has been a day that's been filled with nuggets, broccoli curricula, and unbridled creativity and miscellaneous other stuff. So I've been very excited about it, and thank you for a fantastic session. And I look forward to what tomorrow has to offer. So see you around, and
thank you.
Be good.
Thanks again, everyone.
We'll see everyone tomorrow.
Thank you all.
Bye-bye.
Thank you. Bye. Thank you.
Don't specify the shots, and they'll just give you the right amount.
So the right amount, the standard amount is actually double. And when I say extra, I get a triple. But just don't specify.